Good morning. I'm Professor Praveena from RV College of Engineering. Today I'm going to talk about basics of dynamic routing. So first of all, we'll see the agenda is to introduce about dynamic routing, to find out which is the right protocol for dynamic routing, how to configure the dynamic routing protocols. So first of all, we'll see the introduction to dynamic routing. What is dynamic routing? We can also call the dynamic routing as adaptive routing, which will describe the capability of a system through which the routes are characterized by the destination to alter the path that the route takes through the system in response to a change in conditions. That is, how to forward the data between the subnets. Which layer of the OSI model is responsible for this dynamic routing? That is the network layer or the layer 3. And how do we reach the destination? That is, how it provides the end-to-end reachability. So when we talk about the dynamic routing, it uses something called as routing protocols that dynamically discovers the network destinations and it finds out where it has to be reached to. So this dynamic routing allows routing tables in the routers to change their routing tables if there is any change in the route which is either added newly or deleted from the network. So what is the routing decisions made and how it is made? So basically it is dependent on the routing table. So the routing table will be maintained for each and every router which is belonging in the network. So when the routing table maintains a route is being maintained, so we have to check what is the destination IP address, and depending upon the destination IP address, it will be forwarded to. Once you check the routing table or you build the routing table, it depends on the topology of the network, or whether you do it using dynamic approach or a static or a manual approach. So when we talk about this dynamic routing, so each and every router will have its own routing protocols running in it. So whenever you run the router or whenever the protocol is being run on the machine or the device, so it continuously exchanges the status. It updates the routing table. So that is the reason we call it as dynamic routing. So what happens here is the routing updates are something like the messages which are sent from one host to the other host, or the router continuously checks whether there is any new addition to the network or deletion of the network, etc. So when we talk about the routing protocols, there are certain protocols which is very necessary. So the basic types are distance vector routing protocols, link state routing protocols, and hybrid routing protocols. So when we talk about your distance vector routing protocol, we have some simple algorithms to find out the shortest distance from one router to the other router. So when you talk about a distance vector routing, we can talk about many metrics which can be used. The distance can be the metric, the number of hops can be the metric, the queue distance can be the metric, the delay can be the metric, and etc. So, for example, the Routing Information Protocol version 1 or the IGRP, that is the Interior Gateway Routing Protocol, are some of the examples of a distance vector routing protocol. But even though it is a routing protocol, but it does not use a dynamic approach. It solves the shortest path using a static approach, but it does belong to the routing protocol. Coming to the link state routing protocol, it uses something called as a dynamic approach. So what it does is, each and every time the router updates the table, so it just finds out that dynamically how the routing table will be constructed at each and every router level. Example, your OSPF, your ISIs, that is open shortest path first, and your intermediate system to intermediate system. So talking about hybrid routing protocols, it uses the combination of both the static approach as well as the dynamic approach. That is, it incorporates the advantages of both the approaches and minimizes their disadvantages. So you can talk about your RIP, that is Routing Information Protocol version 2, or Enhanced Interior Gateway Routing Protocol, that is EIRG. So after choosing the basic protocols, it's our duty to find out which is the right protocol which we have to use for or use within the network when we construct a network. So when you talk about your choosing the right protocol, it's mainly depending upon where your network is or what is your network, what type of network it is, whether it is an autonomous system or it is within the autonomous system or across the autonomous system, etc. So when you talk about your system, that is your autonomous systems, we talk about interior gateway routing protocols and exterior gateway routing protocols. So interior gateway routing protocols or interior routing protocols, it is nothing but it should be used within an autonomous system where you have an administrative control. When you talk about your exterior gateway protocol or a routing protocol, it will be used across the autonomous system, that is between the autonomous system, where one particular router will be helping to contact the other router in the other network. So when you choose this interior routing and exterior routing protocols, these are some of the protocols which you've already seen in the previous slides. So it is static, RIP, OSPF, EIRGP, ISIS, exterior routing, BGP. BGP is border gateway protocol. So that is what, I'll just give the details about what is dynamic routing protocols, that is your routing distance vector, which is a static protocol, which is routing information protocol, interior gateway, enhanced interior gateway protocol, etc. Link state is your OSPF and ISIS. Path vector is nothing but your BGP, which is nothing but your exterior gateway protocol. So when you talk about your RIP, so this belongs to the RFC 105. So it's a classful and doesn't support authentication. So when we talk about your version 2, it is classless and it supports CIDR, classless inter-domain routing protocol, and also supports authentication. And you can use hop count as your routing metric. It converges very slowly and not very scalable. It just limits to only 15 hops. When you talk about your IGRP, this was invented by Cisco to overcome the limitations of your routing information protocol, which can allow up to 255 hops. And here, it also allows multiple route metrics because all your RIP will allow only distance as the metric. So you can see the previous slide, it just allows the op count as your routing metric, but whereas your IGRP allows bandwidth, delay, load, maximum transfer unit, reliability, etc. And here again, it supports classful addressing. So when you talk about your RIP, so next is your EIGRP. It is Enhanced Interior Gateway Routing Protocol, which is replaced by IGRP. Here the advantages are it maintains a topology table where you have successors and feasible successors. So here it allows multiple routing metrics. It's again classless, it supports CIDR, it converges very fast, and it maintains neighbor relationships. And it also supports diffusing of data algorithms and not as CPU intensive as OSPF. OSPF is very intensive algorithm. So what is OSPF? Open shortest path first. So it's an RFC 2328 and neighbor relationship is being maintained, and different areas can be used for controlling flooding of your routing information. Again, classless, fast to converge. But the only thing is designing is a little bit complicated when compared to the other algorithms. So ISIS uses Dijkstra's algorithm and it's mainly used by large service providers and etc. So coming to your BGP, so BGP is mainly Border Gateway Protocol, which is in RFC 4271. So here what happens is we use a concept called multi-homing to ISP. ISP is Internet Service Provider. So it's very scalable, it makes decision upon the autonomous system part, and we have lots of policy options and etc. So the last topic here is configuring your dynamic routing. So how do you configure your dynamic routing in a network? So first job is to choose a protocol that meets the needs of the vendor, and each and every vendor will have their own specific commands for the routers. So you have to plan well to ensure a functional network, create a diagram and see to it supports the high technology, that is the standard of the technology should be high, such as HSRP and VRRP. So if it supports this, then it will be fine. We will not have any problem in configuring the routers. So best practice for configuring this: enable your routing protocol for interfaces which you intend to use. Because if you cannot just compromise telling that you will use all the routing, the routing protocol will be implemented on all the routers. So whichever interface you are supposed to use, please enable the routing protocol only in that particular interfaces. And if you compromise on these things, then it will create lots of problems. If possible, enable authentication, because authentication will help us to ensure to reach the destination. So again, advertisements. So allow only networks to be advertised that should be advertised, and use a private address spaces, that is which belongs to the organization, and also see to it that when it is being sent outside the organization, you use a address which is a global address, because before sending it to the ISP, your local address will not be supported. So with this basic information about routing, dynamic routing and routing protocols, I end my presentation. Thank you.